Good morning, students. So we are going ahead with module 4. The first topic that we have seen in module 4 was clustering with k-means clustering algorithm. Now the next topic is rule-based system identification. First, let me ask you, what is system identification, or you can call it system modeling? So system identification or system modeling is the task of achieving a set of input-output relations that describe a process. That is, if you are having a process or a plant or anything, any system, that system will have certain inputs and it will have outputs. Obtaining a relation between the input and output is called system modeling or system identification. So just obtaining some relation between input and output is called system identification. So in earlier days, conventional mathematical approaches were used for system modeling. And the main problem with that is that it's not able to handle uncertainty. And if the input-output relation is non-linear, it's very difficult to find the structure of the relation between input and output. So if you're going to fuzzy modeling or fuzzy system identification, it would be better because it can accommodate uncertainty and non-linearity well. So that is why we are going for rule-based system identification or fuzzy rule-based system modeling. So any system modeling problem or system identification problem has two stages. First is called the structure identification and the second is called the parameter optimization. Now, what is structure identification? You know that for any fuzzy rule-based system, there will be fuzzy rule base. Rule base means a rule, it has different rules in that. So, structure identification mainly means how many rules the rule base should have and what should be the structure of the rules. That is, if x is a and x1 is a1 and x2 is a2 and so on, then output y is so and so. So how many parts should be there in the antecedent? How many parts should be there in the consequent? What is the nature of the consequent? Whether it is Mamadani or Sugeno. If it is Sugeno, is it first order or second order? What are the coefficients? Everything, how many coefficients should be there, all comes under structure identification of the rule base. Next is parameter optimization. It involves finding the parameters, that is parameters in the membership functions and parameters in the consequent. So what do you mean by this parameters in the membership function? Suppose you are taking a triangular membership function. So triangular membership function will be something like triangle shape. So you will have a starting point for the triangle, you will have an ending point for the triangle, you have a peak. So if you are making a fuzzy set for temperature, you should know what is the starting point of temperature, what is the ending point of temperature, what is the peak, what is the range, everything. All those involves the parameters in membership function. And what are the parameters in consequent? If you are using Sugeno, you need to know if it is a first order one, what are the coefficients? Like if first order you are saying output is equal to A0 plus B1x1 plus B2x2. You need to know what is A0, B1, B2, etc. So this is what is called parameters. So Once you identify the structure of the rule base, that is how a rule should look like and how many rules should be there, then you need to find what is inside those rules. What is fuzzy set A1? If it is triangular, what is the starting point, ending point? All those comes under parameter optimization. Now, what is the significance of fuzzy reasoning? It's very similar to human reasoning. Means it uses the same logic or way of thinking as humans. Like if temperature is cool, then switch the fan off. So we are discussing or describing everything in simple ways like human beings. So what do? You have many steps like fuzzification, where we find a match between the rule antecedents and the inputs. Then a number of rules will be triggered and all the rules will be together aggregated and defuzzified. This is what happens in fuzzy rule-based modeling also. So how we can form the rules? Usually in fuzzy modeling we can extract knowledge from human experts and transform that to rules. Suppose we need to make a rule base for a plant. So the experts who are operating that plant would know what are the range of inputs, what are the range of outputs. So he can generally make some rules out of that. And then we can try those rules using some trial and error methods. So what is the problem with this? The main problem with this is that human expert knowledge is often incomplete and it can also be subjective, and rule-based knowledge based on just single person or something will be difficult and it can cause error, and according to newly arriving information it's very difficult to update that. So researchers have been trying to automate the process of fuzzy rule-based modeling based on training data. That is, to a fuzzy system you have some inputs and you have output. If you have that data, input-output data sets, you train that fuzzy modeling like in ANFIS. Now, as I told you earlier, a rule-based system identification has two parts. It is structure identification and parameter identification. So, structure identification means finding suitable number and structure of rules and what is the structure of consequent, whether it is first order, second order, and so on. And parameter optimization depends upon the adjustment of system parameters such as all the things in membership functions, everything in consequent function, and whether the antecedents are combined using AND logic, OR logic, and so on. So this is a rule base here. You have different rules, inputs are acting on the rules, and each of the rule will give you an output. It will be combined to produce an output. Now, we'll go to the core of today's topic. What are the steps involved in rule-based system modeling? So, like I told you before, you have structure identification and you have parameter identification. Okay? And before that, let me tell you, a fuzzy rule is of this form. Okay? If x1 is a1, x2 is a2, etc. up to xp is ap, then y is equal to c0 plus e1 x1 plus e2 x2 plus etc. cp xp. Here we are assuming that there are inputs from x1 to xp and output is first order, so gain. So here this I superscript refers to the first rule. Similarly, you can have many rules in the rule base. So if it is the second rule, you put L2. Everything will have the 2 superscript. Okay? This is one explanation. I think it is self-explanatory. So all the rules may not have all the input variables. Look here, the first rule is having just one input variable. It can also happen. So this is just a refreshing of what is rule and so on. Okay. Now we will go to the steps in fuzzy rule-based system modeling. First is generating the rule base from data. Second is selecting the important input variables. Third is determining the optimal number of fuzzy rules. Fourth is optimizing the parameters in antecedent part and consequent part. And the last is obtaining the optimal fuzzy model by removing the redundant membership functions. We'll go to each step. Generating the initial fuzzy rule base from data. So I told you, like, if you have a system, you have a set of input data and output data. What you can do is you plot that input output data on a scatter plot. Use some neural network classification procedure to classify that data set into different classes. That is first you are doing. You have an input output data set. You can use supervised classification using neural network to classify that data. Or maybe you can, if you are having just input data set, you can use unsupervised learning. Anything will do. And then for each cluster, it will have a cluster center like this. For example, for the first cluster, A1, B1. So each cluster center can be made into a rule. This is the crude form or initial form of fuzzy rule from the data given. For example, if the input is around AI, output is around BI. That is, if input is A1, then output is B1. This is the meaning of that. You get in the form of a fuzzy rule. So what you have to do first is you obtain the data. For example, if you are having input output data or input data alone, anything will do. You cluster it using neural network, either using classification technique or unsupervised learning. Clustering can be used. Clusters can be formed, cluster centers can be formed, and you can create the rule from that cluster center. This is the first step. Now, selecting the important fuzzy variables. Now, there will be many variables for a fuzzy system. Now, in order to reduce the dimensionality, for example, the input vector can be x1, x2, etc. up to xp. So, some of the variables in that may be not important. So, we have to remove that in order to reduce the input dimensionality. So, how we can find that is that you find the contribution of each input variable to the output. So, if x1, the first input causes a large change in output, it means that x1 is very important. If x3 is having only a small output change, it means that x3 is not important. You can remove x3. So what you do is, all the antecedent clauses except the clause with the chosen input variable is assigned a truth value of 1 and the output corresponding is computed. So I can explain this using an example. It is just for your understanding. Please don't write it in exams, okay? See, I have 4 rules like this with 4 parts in the antecedent. x1, x2, x3, x4 are the input variables. Z is the output variable. Like that I have three rules. Suppose, okay, it is rule 2, it is rule 3. Now, for calculating the importance of variable x1, what you do is, you make all the others except x1's part as 1. So when you AND it, it is equivalent to just x1 is a1. So if x1's impact is need to be found, for example, for this rule, if you have calculated, falsified this and made the value is 0.4, then this whole rule gives 0.4 value. then the output can be calculated for each rule, and the total output can be calculated. Then how much effect x1 is having on the output can be found. Similarly, for all the other inputs x2, x3, x4, it can be calculated. Now deciding the number of fuzzy rules. So determining the optimal number of fuzzy rules depends upon determining the optimal number of clusters. So there are numerous fuzzy clustering algorithms which can find the optimal number of clusters. For example, you can use fuzzy C-means or K-means clustering. So once the optimal cluster centers are formulated, the optimal number of rules also can be found. So finding the optimal number of rules depends upon finding the optimal number of clusters. So this is the last two steps, optimizing the parameters in the antecedent part and consequent part. So optimizing the parameters in the antecedent part involves the parameters in the membership functions, and consequent part involves the coefficients in the first order Zucchino. So all these can be optimized using backpropagation. Just write like this. Okay. Now it is model simplification. So you have to remove redundant fuzzy rules. If a rule is occurring 2 times, or if some fuzzy set is always near to 0, just remove that rule corresponding to this membership. And if 2 fuzzy sets are similar, similarity can be measured based on certain indices. If 2 fuzzy sets based on some similarity measure are found to be similar, just remove that. So that's all about rule-based system modeling. I've tried to make it as simple as possible for you. Please go through at least 2 or 3 times so that you get a concept on this. Thank you.